In this video, we present our system to create high-quality, free viewpoint video that can be compressed to bandwidth suitable for consumer applications. This example is a traditional Maori haka performance. We start by capturing performances with 106 synchronized RGB and infrared cameras on a calibrated green screen stage. We subtract the background to compute silhouettes, then schedule the data for processing. The first step generates a 3D point cloud starting with stereo depth maps from RGB and IR pairs. Points from these depth maps are merged and refined locally. Then the cloud is refined globally using a multi-view stereo algorithm. This result has over 2.7 million points with normals per frame. We're viewing tens of thousands of points in this scene. The next stage creates a watertight mesh per frame. We modify screen Poisson surface reconstruction to produce meshes constrained by the silhouettes. These meshes typically have topological artifacts and spurious components. To clean them up, we apply topological denoising and island removal. This result has over 1 million triangles per frame. Next, we determine which areas contain perceptually important details such as hands or faces. We preserve the quality of geometry and texture in these areas when we decimate the mesh to its target density. This example is reduced to 20,000 triangles per frame. We then establish temporal coherence by choosing mesh keyframes and deforming them to fit ranges of the performance. This coherence is critical for compressing mesh motion and textures. This example was split into 4 subsequences. The final step is to unwrap the meshes, generate a texture atlas, then compress and encode the data in a single streamable MPEG file at our target bitrate. This example is running at 12 megabits per second. Let's take a look at some example captures from our system.